Hello and welcome to Dr. Anima Upadhyay's Chemistry Lab videos. This video is in continuation with my previous video in which I have discussed with you the miscellaneous viva questions on the instrumental techniques. I thought that I should take more time to discuss with you on the electrode and electrode potential, which is the basis of all instrumental techniques almost. So let us begin. But before I begin, I would like you to subscribe my channel and don't forget to share my videos and like them. It will inspire me to prepare more videos for you, which will be very helpful for you to prepare for your exams. What is an electrode? An electrode is a metal strip of wire which, when immersed in a solution of its own ions, develops a potential and is capable of undergoing either oxidation or reduction. Such a metal strip is called an electrode. What is electrode potential? The tendency to undergo oxidation or reduction is called electrode potential. What is oxidation potential? The tendency to undergo oxidation is called oxidation potential, and the tendency to undergo reduction is called reduction potential. What is oxidation and what is reduction? Loss of electrons is oxidation and gain of electrons is reduction. If two metals such as zinc and copper are kept in a solution of its own ions and they are connected to each other with a wire, which one will be getting oxidized and which will undergo reduction? In such a cell, the copper being at a higher reduction potential will make the zinc to undergo oxidation and itself it will undergo reduction. What is the standard reduction potential of copper? It is 0.34 volts and zinc is at minus 0.76 volts. So copper is at a higher reduction potential compared to zinc. What is a galvanic cell? A galvanic cell is one which undergoes spontaneous redox reactions. And in this cell, there are two compartments called anodic and cathodic compartment, consisting of electrodes made up of different metals which are kept immersed in the solution of their own ions. And the two half cells are connected with the help of a salt bridge. How the salt bridge is constructed? The salt bridge construction is very simple. It is made up of a hollow glass tube which is filled with an aqueous solution of an electrolyte such as ammonium nitrate or potassium chloride, and agar-agar is mixed to it, which is a colloid, so that the solution does not flow out of the glass tube, after which the two ends are plugged with the help of glass wool. One end of this salt bridge is immersed in anodic compartment, the other end is immersed in the cathodic compartment. What are the functions of a salt bridge? Salt bridge maintains the electrical neutrality because it allows the passage of anions from anodic compartment to the cathodic compartment. It does not allow the mixing of the solutions in the two half cells. It maintains the flow of the electric current. What is the role of calumal electrode? Calumal electrode is a secondary reference electrode. And with the help of calumal electrode, we can determine the electrode potential of any given electrode. Can we use calumal electrode both as anode as well as cathode? Yes, we can use calumal electrode both as anode as well as cathode. What type of electrode is calumal electrode? Calumal electrode is an example of metal in contact with its sparingly soluble salt, kept in contact with the solution containing the same anions as the sparingly soluble salt. Can you elaborate your answer? Calumal electrode, the mercury is a liquid metal which is kept in contact with its sparingly soluble salt, that is mercurous chloride Hg2Cl2, which is also called calumal, and they are kept in contact with potassium chloride solution. So potassium chloride solution and calumal has the same anions, that is chloride ions. So metal in contact with sparingly soluble salt of its own ions, which is then kept in contact with the solution containing the same anions as the sparingly soluble salt. Can you give any other example of this type of electrode? Silver chloride electrode is also same type of electrode, where silver metal is kept in contact with its sparingly soluble salt, that is AgCl, which is then kept in contact with KCl solution. In these electrodes, how does the potential varies? The potential in these electrodes varies with respect to chloride ions, Cl ions. And it is given by the Nernst equation. E is equal to E naught minus 0.0591 log Cl. Can you elaborate your answer? The concentration of potassium chloride solution affects the potential of the electrode. With the saturated calumal electrode, the potential is 0.2422 volts. With 1 molar concentration of potassium chloride solution, the potential is around 0.28 volts. And with 0.1 molar concentration of potassium chloride solution, the potential is 0.344 volts. So, with the rise in the concentration of potassium chloride solution, the potential decreases. This is what the Nernst equation also states. E is equal to E naught minus 0.0591 log Cl. So the potential in the calumal as well as silver chloride electrode varies inversely with respect to the chloride ions. Can you give the applications of calumal electrode? Calumal electrodes are used in all potentiometric titrations as a reference electrode. It is also used to determine the electrode potential of any given electrode when it is combined with the calumal electrode. What are the applications of silver chloride electrode? Silver chloride electrode is used in all the ion selective electrodes as internal reference electrode. It is also used to determine the potential of the underground pipelines. If you are performing pH metry, you are using what type of electrode? As a indicator electrode. The glass electrode is used as indicator electrode in the pH metry. Which electrode is combined with the glass electrode as a reference electrode? Calumal electrode is used as reference electrode in pH metry. It is combined with the glass electrode. What is the glass electrode made up of? What type of glass? The glass electrode is made up of a special kind of glass called the soda glass. But it is the lower portion of the glass electrode, that is the glass bulb, which is made up of soda glass. The upper tubular portion is made up of ordinary glass. What are the characteristics of soda glass? It has a low melting point and high electrical conductivity. What is the composition of soda glass? The soda glass is a mixture of oxides of silicon, sodium and calcium. Silicon oxide is 72%, sodium oxide Na2O is 22% and calcium oxide is 6%. What is the liquid filled in the glass bulb? It is 0.1 normal hydrochloric acid which is filled in the glass bulb. Where does the potential develops? At the glass electrode. The potential develops in the glass electrode at the interface between the glass bulb and the solution. What is this potential called? It is called boundary potential. When you're performing a conductometric titration of a weak acid, that is acetic acid, with the strong base, that is sodium hydroxide, what type of curve will you get? The curve will be sudden decrease and then there will be a gradual increase till the equivalence point is reached. Beyond the equivalence point, there will be a sharp increase. Why a sudden decrease and then gradual increase? The sudden decrease is because the acetic acid is a weak electrolyte, so it is partially dissociated. But as soon as the sodium hydroxide is added, it reacts with the acetate ions, forming a strong electrolyte, that is sodium acetate, which results in a gradual increase beyond the equivalence point. When all the hydrogen ions are neutralized by the hydroxyl ions, only the hydroxyl ions are in excess in the solution, which results into a steep increase in the conductance. What type of curve will you get when you are performing a conductometric titration of hydrochloric acid versus ammonia? In this titration, the curve will be, first there will be a sharp decrease. Beyond the equivalence point, there will be a very slow decrease. So it will be almost same. Because the ammonia is a weak electrolyte, so the hydroxyl ions, which are highly mobile, will be less in number available, and there will be a very slow decrease in the conductance. But before the equivalence point, there will be a sharp decrease because of the highly mobile hydrogen ions present in the hydrochloric acid. Now, I think I have discussed most of the questions with you, which are going to help you very much for preparing the Viva OC in studying the instrumental techniques. Keep watching the videos. Thank you for watching this video and giving so much of time. Take care of yourself.